So you think with all the people talking about how robots are going to take over, that it would have actually happened already. But the fact of the matter is, we're actually still in the beginning stages of the robotics revolution. And for me to actually illustrate how robotics is going to change society, first we're going to talk about what robotics is, then we're going to look at a brief history of robotics, and then I'll show you some applications that I find really cool and I think have the possibility to really disrupt society. So in its most basic form, a robot is just a machine that can think, sense, and act. And this very much imitates the way humans behave. For example, if I was walking across the stage and I saw a pile of glass, I'd first receive the visual input that I've seen the glass. I would then think about it, think about my past experiences with glass. I would know it's dangerous, and then I would act by avoiding it. And the first robot that was actually able to think, sense, and act in an industrial setting was the Unimate in 1954. And this was the first industrial robot, and it was created by General Motors. Unimate was designed so that it could pick up metal blocks off of a conveyor belt and weld them. And this provided benefits over traditional human labor because welding is dangerous, both from the temperatures and the fumes, and this was more efficient as well. But the problem with the Unimate was that it was not easily programmable. And so it was specified specifically for this task, but to reprogram it for a different task, it was very difficult. About 20 years later, the IRB Snake came along, and this is actually one of ABB's robotic arms. It probably looks pretty familiar. And this was fully electric and very easily programmed. And so this actually saw a lot of success in the automobile industry, but it was also able to be used in other industries too because it was so easily programmable. And so after the production of this arm, it actually became commonplace in factories for robots to be automating a lot of the work. But we ran into the same issue with this robot that we did with the Unimate, in that it can act well, but it has very basic sensing and very basic thinking. And so if I wanted the arm to move a box from position A to position B, it could do that, but if I moved the position of the box slightly, it wouldn't be able to sense that and adjust. So it was about 5 years later that the Consight Eye came out, and this was a system that was also designed for use in a conveyor belt, except this system had a camera on board, and it could actually distinguish between 6 different kinds of automobile parts on the conveyor belt. So this opened a new field in robotics. How do you process an image such that a computer can understand it? How can you tell a machine that one auto part is different from another? So this opened up the field of computer vision, and it also opened up the field of artificial intelligence, where the goal was to create a machine that can think and rationalize like a human. So the definition of artificial intelligence, I like to use John McCarthy's definition because he looks a little bit like the KFC guy, it's making a machine behave in a way that would be considered intelligent if a human were so behaving. So if we look at the Unimate example, if it's moving blocks from one part of the conveyor belt to another and welding it, that wouldn't be considered intelligent necessarily. But the ability to distinguish between 6 different kinds of automobile parts in real time could be considered human intelligence, artificial intelligence. And the general goal of AI was to create a robot that could think, move, and act like a human. And this is extremely useful in the industry because if you could have a robot that mimicked a human movement, for example, then you could take over the tasks of a human. So it wouldn't just be this arm that was moving something from point A to B, but you could actually have a robot standing there performing the exact task that a human would be performing. And it wasn't until 1997 that AI really took off. And in this picture here, you see Garry Kasparov lost a game of chess. He was the current chess champion at the time, to IBM's Deep Blue, which was a chess AI. And people believed for a long time that there's no way computers would be able to beat humans at an inherently human game. They thought it required a different kind of reasoning. But chess, particularly winning at chess, it opened up the door to a whole new bunch of possibilities. If chess can be won by a computer over a human, what else can robots do? What else are robots better than humans? Now, if I spend the rest of the talk talking about all the history of robotics, I'll be here for over a few days. So I'm just going to focus on some of the robots that I find really cool and some of the industries I think are going to be disruptive. So if you see in this picture here, there have been a lot of developments in robotics since the arms. We have exoskeletons, we have autonomous cars, we have drones, agricultural robots, virtual reality, we even have stock trading robots, and actually the majority of stock trades done nowadays are done by robots. Now, if we look at the military industry, this is a video of Boston Dynamics Atlas robot, and you can see we've come a long way since the Unimate in 1954. So this is about 60 years later, and you can just see that it has unbelievably human-like appearance, but also movements as well. And when I first saw this video, I actually thought it was fake because I thought there was a human standing in a suit. You can even see when it lands and squats like a human does, and it balances itself with its limbs. And so this is kind of the state of the art in control in robotics right now. So if you see this, this requires an immense amount of engineering and a lot of thinking, sensing, and acting in real time to perform those movements. The next application that's extremely interesting as well and very disruptive is the autonomous car. And you've probably heard about it before, and it's even available on the market. And that's something that's interesting about this application over other robots that I'm showing, is that this one is actually for sale. And this is Tesla's Autopilot system. And you can see here, you get camera input to the car, and it's also doing the thinking, sensing, and acting in real time, but also in a situation where it's very dangerous for a human to be in. So one of the few industries that is more dangerous than this to actually program on would be the aerospace industry. And so this just shows that the level of confidence we have in a machine, such that it would be that we would allow it to drive us around in a car. Next industry is one that I'm personally working in right now, and this is the medical industry. And I'm working at the ETH's multi-scale robotics lab, and this machine you see behind me is called the Octomag. And it doesn't look like a traditional robot, but what it does is it's designed for micro-robotic surgery. So the idea is you take a micro-robot and you can inject it into the eye, and then by using a magnetic field and changing strength in each of these magnets, you can actually move the micro-robot around in the eye. And so you can use this to perform surgeries, and you can also use this for targeted drug delivery. And you can coat these micro-robots in a drug and then drive it to a specific part of the eye to deliver that drug. And beyond the Octomag, we also have a CardioMag, which is done for heart surgery. So the idea is you would lay down in this big machine, the magnets are quite a bit larger, and then they would run a catheter up through the femoral vein in your leg, and then when it's in your heart, you can guide it around and actually destroy tissue that's causing arrhythmias, for example. So the applications of this are pretty immense. Also in the medical industry, but slightly different, not so hardware focused, is the advancements we've seen in machine learning. And you've heard about it from some of the other speakers, but it's actually incredible what we've done in the last 20 years. And so in this application behind me, you see that a computer is learning to detect cancer from an image of a tumor. And the really interesting thing about this is that the algorithm that's used to detect cancer here, you can also use to detect the difference between auto parts on a conveyor belt, or the difference between different kinds of fruits on a farm. So it's the same algorithm, but it's applied to a classification task. And the thing is, as it keeps learning from more and more examples, it gets better and better. So the idea is feeding a stack of images of cancerous tumors and not cancerous tumors, and it would learn the difference automatically. And so as that data set grows, in theory, you have more and more accuracy from your algorithm. So the three main points I'd like to take away from this, and how this is going to change society, is one, that data is going to become more and more important. And so as I said with the machine learning algorithm, you get this monopoly kind of effect. And imagine that you want to go to a doctor and you want to get your tumor automatically diagnosed by one of these machine learning algorithms. You would definitely go to the doctor with the highest accuracy rate. And so when you go to the doctor with the highest accuracy rate, not only are you being classified, but you're also being learned on. And so that algorithm will get better and better and better. And so whoever controls the data controls the power. Secondly, more jobs are going to become automated. Now this one's kind of obvious, but it's kind of already happening. And if you think about the ATM, for example, which has been around for a while, we used to have tellers before that. And now it's commonplace that you go to a machine and you interact, you insert your card and get the money back, and there's no human involved. And you saw with the Tesla Autopilot system too, the cars can be autonomous as well, and you can apply that same technology to trucks. And so you can take over truck driver jobs, which is a huge percent of the blue-collar workers in the US, for example. And third of all, I really urge you to familiarize yourself with the technology, because what we see with technological revolutions is that the people who adopt the technology early are the ones who benefit the most, and the people who fall behind are the ones who benefit the least. So I encourage you to look up how robotics can help you in your field, or what's going on in your field, or even talk to somebody. You can talk to me afterwards. And just familiarize yourself conceptually with what's going on. Because if you can take advantage of the technologies that come along, then you can empower yourself. So I encourage you to join the robotics revolution.